All right, welcome. Today we're going to jump in and talk about achieving scalability and performance with vVols on Pure Storage for Oracle workloads. Today I've got Sudhir with me and my name's Jason. So let's get into that. So here's how we're going to go through this. We've got a little intro into vVols, talk about some traditional challenges with virtualized business databases, some vVols use cases, some takeaways, and then we'll jump into the conclusion. So let me jump into a quick vVols intro. If you're not familiar with vVols, vVols are becoming more and more popular. And kind of the easiest way to think about what a vVol is a well-orchestrated RDM. And the reason we say it that way is the vVol object itself physically resides on the array as its own entity. It's not a file on top of another file system. So there's no VMFS, there's no NFS. Whatever the guest OS file system is on that object is the file system sitting on the array natively. So we kind of call those a first-class citizen because each object that the VM uses those objects are dedicated to that VM. And there's some benefits to that. When you don't have a file system, there's no secondary layer that the information has to pass. The VM is directly accessing its object and that disk. Very similar to an RDM, but without some of the losses that you get in functionality in the virtualized environment. Now, there's some other benefits too with that direct connection. You can also do stuff like pass, trim, or unmap directly to the array. So if the guest OS supports trim or unmap or some type of space reclamation, when it initiates that, instead of that being passed down to the kernel and to the file system, and then the file system acknowledging that and then passing it to the array, that command is actually directly passed to the array. So with that, you get very efficient space reclamation. Another big benefit here is that with vVols, you're no longer provisioning LUNs or volumes. So unlike a traditional infrastructure where you would provision a LUN or a volume and it has a certain set of capabilities, with vVols, the architecture and the management around vVols does that for you. So when you provision a VM and you create a new VMDK, that's done on the back end on the array for you. So you don't have to go create that object. And with that, there's some benefits now because instead of that object being in a specific data store with a specific capability, as in the case with VMFS or NFS, the array presents all of the capabilities up to the environment and it's managed via policy. So now you can manage your storage capabilities at a VM level using policy-based management. And then the other thing that's very nice is that with supported arrays, and Pure does support this, you can do array-based replication at a VM level. So no longer do you have to do replication of an entire volume and everything inside that volume. You can set up replication for a single VM. Another benefit here on the replication is you can do replication from one to many. So you could have one set of VMs go to one replication partner, as we call it, and another set of VMs go to a separate replication partner. And those can all come from the same source data store. So very unique function that you can do with vVols. Now, when we go into and we look at traditional data stores, if you had a VM, and there's a good example here that's got multiple disks, when that VM is in one data store, it has the capability is the same on both disks. So if you wanted to change the capability of one disk, you would actually have to put it in a separate data store. And so that kind of adds complexity to your environment. If you look at vVols, what makes this unique is because each object is its own entity, you can have one disk with one storage capability and one disk with a different storage capability, and those reside in the same data store. Because remember, each one of these objects is its own object or its own entity sitting on the array. And so there's a lot of flexibility in that functionality, because now each object can have different functionalities or different storage capabilities based on the policy that you apply to those objects. So when we think about kind of the overall process and how this works, we have a storage administrator goes in and creates what we call a storage container. And this varies from array vendor to array vendor, but what this is just a logical grouping of the vVol objects themselves. Sometimes it's the entire array, sometimes it's a folder. It really varies from different vendors. But the idea is when you provision this storage container, it's a logical quota. You're not actually provisioning any physical objects. So in this case, if you wanted to provision 30 terabytes or 30 gigabytes, it doesn't matter, because there's not actually any space used until you move a VM into that storage container, which maps one-to-one to a vVols data store. So in this case, we've got the storage container has been created. Then the VI admin gets to go in and create the vVols data store. Once the vVols data store is created, the VOSA will have already been registered. And we have these things called protocol endpoints. I'm not going to go into those in detail, but basically they're like a proxy access point for the vVol objects themselves. Once that's done, all of the capabilities are then presented up. And then based on security, organizational requirements, performance requirements, whatever it might be, you can then go create these storage policies that can be then applied to the VMs or the VM disks, depending on how you want to do this. And remember, each object is its own entity sitting on the array. So you're not applying a storage capability to the data store, you're applying it at the VM or the VM disk. So you have a lot more autonomy in managing the storage capabilities. Then once you've got the storage policies created, you can provision VMs. Those VMs then have those policies applied. And then when you power on a VM, the IO path is established to that VM's related objects. And so there's a very efficient process there, because rather than sharing a LUN across all hosts all the time, that VM is accessing only its relative vVols. Another big benefit here is that when we start looking at a vVols data store looks the same as a regular data store. You can use all of the same tools, Power CLI, do same scripting. The difference is how it's instantiated on the back end. And as a vSphere administrator, you don't have to worry about that because it's all handled within the vVols architecture. So that just kind of gives you a quick overview on vVols and kind of how they work. So now I hand it over to Sadir, and he's going to kind of talk about some of the things we were mentioned in the intro about how we can use Oracle on vVols and what are some of the benefits. Sadir, it's all yours.
All right. Thank you, Jason. All right. So, let's now talk about how virtual volumes or vVols, they can help business critical workloads. So in this section, we'll be focusing on day two operations, right? So as you can see in the slide here, right, essentially, right, any business critical workload, they will have certain SLAs, they have certain RTOs, they have certain RPOs, right? And they also have a set of stringent requirements. And some of the requirements include like high availability, performance, recoverability, scalability. You need to scale up, you need to scale out your database on the fly, right? And also, there are some strict requirements for day two operations to complete in timely fashion. For example, you have a backup window of 3 hours, and let's say you have a big database. You want to make sure that your database backup gets completed timely within the 3-hour window. So what happens is with virtualization of Oracle workloads, customers, they have certain concerns, which includes, databases. Different databases, they have different levels of criticality, right? Every database needs different storage, performance, characteristics, and capabilities. That's one. Second, there's a challenge trying to meet stringent performance for stringent SLAs for performance, which typically with slow traditional arrays storage. Now, with the rapid growth of databases, the need to reduce the backup window, as I mentioned before, to meet performance and business SLAs, that grows as well, right? What also happens is, as and when the database grows in size, day two operations, which typically all Oracle DBAs do, like for example, cloning databases, or if you have to do a database refresh, or if you have to, let's say, provision a database, for patching or any kind of software testing. Now that becomes a big challenge here, right? But last but not the least, using storage-based replication as well, what happens is, even though that's superior in speed, but unnecessary data gets copied over. Even though the fact that the speed is superior, but unnecessary data gets copied over. As compared to any kind of application-based replication. Now, let's take a use case here. The use case that we're looking at here is the Oracle database, backup and restore, right? So if you look at an Oracle backup and restore use case here, well, that particular use case, which is backup and restore, that can be triggered in three different ways. The first level is the application level, essentially the Oracle database level. You can use a tool like Oracle RMAN to trigger the Oracle backup and restore. The second level where a database backup restore can be triggered is the virtual machine level, the VMware level. And last but not the least, you can trigger the same backup and restore using storage-based mechanism. Now, there are pros and cons to either of the three approaches here, right? Let's start looking at the pros and cons for every approach. For example, if you're looking at the application level, the Oracle database level, the level of granularity is very fine. You are able to back up at a table space, at a data file, or even at a table level granularity. But the cons or the disadvantage of the approach here is it's not always the fastest. So essentially, when the size of the database grows, the time it takes to do a full RMAN backup, essentially that kind of tapers off, right? So that's the challenge when we use any kind of application-based, backup tools. Now, when we start talking about the second level of backup, which essentially is the VMware level backup, right? The VM level granularity is something that's ideal, and that's something that once you virtualize your Oracle workloads, and that you can do using any VMware-based snapshot technologies, right? But the disadvantage to that is sometimes when you have a VM level snapshot, that might stun a virtual machine for some time during any kind of snapshot coalescing or deletion. And there's a KB article to that as well. So that's why when we have customers doing, taking VM level snapshot of databases for any kind of backup purpose, what we recommend is when you have to delete it or when you have to coalesce it, do it during a quiet time when the database is quiet, when you're not running any jobs or when you're not running a big load on the database, right? And then when we look at the third level of taking a backup and restore, which essentially is the LUN level, which is at the LUN level or the storage array level, right? Speed and the performance is awesome, right? But the thing that it lacks essentially is the VM level granularity because the operations are executed at a storage level. So essentially what we get is VMDKs of other virtual machines as well on the same data store. Now, what is our end goal? Our end goal is to combine VMDK level granularity with the speed of storage array for any kind of database day two operations, whether that's backup and restore, whether that's database refreshing, whether that's DB cloning or DB patching, so on and so forth, right? And essentially, this is where VMware vVOLS technology provides an ideal solution to the challenge here. So you're able to now combine the VMDK level granularity with the speed of storage array for any of the database day two operations. All right. So what happened this year was 2021. We came up with the reference architecture. Essentially, we released the reference architecture, which validated the following day two operations for both an Oracle single instance database and Oracle RAC instance, right? On vVOL using pure storage flash array X50, right? The use cases that we basically went through the reference architecture was there were the database backup using vVOL-based snapshots and Oracle RMAN. We essentially also had the use case of database restore and recovery using vVOL-based snapshots and Oracle mechanism, database cloning, database refresh, database patching, and also VM provisioning and cloning using vVOL's SPBM, right? And the link at the bottom of the slide here that points to the reference architecture paper. Right. So in conclusion, right, business critical databases, they are among the last, they're last of the bastions, right? Last of the workloads to be virtualized, primarily because of the challenges posed as these workloads, as these databases, they grow up they grow in size and they grow in scale. I mean, challenges as, making sure that the backup finishes in a timely fashion, so on and so forth, right? The other critical thing is meeting these strict business SLAs for performance, making sure that we are able to manage these rapidly growing production databases. We need to reduce the backup window, and we need to make sure that the impact on system performance, right, that isn't too much, because that will often force DBAs to delay virtualization of business critical databases and workloads, right? Again, if you look at day two operation, which typically every Oracle DBA has to do in his or her life, right? The frequent demand for Oracle database cloning, refreshing, patching, that further complicates matters. So essentially, vVOL, virtual volumes, they address the challenge of day-to-day operation that includes any of these day two operations, the backup recovery, the cloning and database provisioning, and so on and so forth. And this particular slide, I mean, there are a couple of resources that we listed out here. Essentially, the one-stop shop is everything and anything to do with Oracle on VMware. Essentially, any collaterals that you're looking for, whether that's Oracle best practices, whether that's Oracle RAC, or that's Oracle on vVOL, or Oracle with persistent memory, or RDMA, anything and everything, including licensing collaterals, can be found in the link up here. I think, Jason, you have also provided the VMware vVOL resources link at the bottom of the slide as well.
Yeah, so I've got lots of collateral there. And if you're new to vVols, both Pure and VMware have got a lot of resources on what they are, what you can do. One of the nice things about vVols as well is that it's not a replacement of your existing data store types. A lot of times customers are supplementing, and that allows you to then be able to go and do some of the testing without impact. So especially with Pure, you can have a VMFS and a vVols data store in parallel on the same array. And that allows you to then just do a storage vMotion into a vVols data store and test some of these functions. See how well a array-based snapshot works. See how you can use some of these functions on a database like Oracle and be able to actually utilize array-based functionality in the virtualized environment. So that's really why we're seeing a lot of adoption with vVols, is because of that capability, right? Customers wanted all the benefits of virtualized functionality, vMotion, storage vMotion, that type of thing. But then when we started doing some of the array-based functionality that we used to use in the database for snapshots and stuff like that, you lost that functionality. Well, vVols gives us both. You get all of virtualized functionality and you get some of the array-based functionality back that you're used to using when you're using bare metal. So vVols really is kind of the best of both worlds.
Yep. I think we are at the end of the session here. So thank you for listening to us.
Yeah, and if you have any questions, my Twitter handle is @JBMasay. And Sudhir, we can reach out to you. How?
The same Twitter handle. So it's @VRACDBA. That's my Twitter handle.
Okay. Thank you very much for tuning in. Hope you have a great day.
Thank you.